This session I'm really excited about. When I saw the submission come in, when we had the call for papers, I was excited just by the title. You're going to see a Windows 2003 app, which is not the exciting part, but you're going to see the Windows 2003 app get moved into containers, but you're going to end up seeing function-based computing and serverless computing and all kinds of really fun things. So it's a really good talk, fast-paced. And this is Indy and Arthur, who are with Capgemini in the UK, who are here to take you through it all. So take it away, gentlemen.
Oh, all right.
Hi all. Okay, so making legacy legendary. So what we'll do quick introductions about ourselves. We'll paint the landscape a little bit about what our clients are doing, the behavior that we're seeing from them, and the requirements. And then we'll really start to break into three distinct sections of the talk. The first one being mainly focused around Windows 2003 and what we've done in that space. Then we touch on microservices and also functions as a service. So about us. Arthur, you want to start first?
Yep, so I am a senior platform engineer at Capgemini UK. I've been with the company about 8 or 9 years now. My main background is in live support or ops, in the old-fashioned days. Mainly in the last 2 years, I've been building container orchestration suites in AWS, all as infrastructure as code, all in auto-scaling groups, all self-healing and all ephemeral.
So I've been with Capgemini now, just turned 13 years. And most of that time has also been in the environments and platform space. Over the last few years, we've seen a big shift in the way we work and how we design our environments. So moving away from physical data centers to more commodity tin, virtualization, public cloud and private cloud. And I've been fortunate enough to build quite a few of these platforms. But over the last 2 years, like Arthur said, we've been focusing more on containerization platforms. So we have built 3 Docker Swarm-based platforms over the last 2 years. And the one we're going to be talking more about today is the latest incarnation of that, which is based around Docker EE. So a little bit about our landscape. So what we're seeing from our clients is they want to stay cloud agnostic wherever possible. So nobody wants to get tied in with a cloud vendor. So we're constantly getting asked for multi-cloud environments deployments. That brings with it complexity. So how do you do cross-cloud app deployment? What we want to try and avoid is having to do things differently in every cloud provider, because that's more to manage, more pipelines get complexity. And when you start to go down that route, you have to lower yourself down to the lowest common denominator across all your cloud platforms. So that was a challenge for us. Likewise, how do you scale then? So how do you scale across clouds? You have to have something that knows what's going on across all of your cloud platforms to be able to efficiently scale up. Having the ability to add new clouds dynamically. So one of our CIOs said he wants to go to sleep with all his infrastructure running on AWS, wake up in the morning with all it running on Azure. That's a challenge, but it's not unreasonable. And it has to be fault tolerant. So going multi-cloud, if we have an outage in any one cloud provider, we need to be able to react and still have a full service. Last year, all the 3 biggest cloud providers had region outages, and that for us was one of the key drivers, is to stay cloud agnostic, multi-cloud, but still be able to handle an outage from any particular cloud provider. And Windows. So Windows containers is something that was new to us, which we've been working on about a year. And what that really came out of was a colleague and I were invited by Docker last year, about this time, to attend their MTA program. So MTA is Docker's Modernizing Traditional Application Training program. And as part of that, we were involved and we did some work around how we can take some legacy applications and put them into containers. So not just for greenfield applications, but some of the older stuff as well. Out of that, we went away and we had a think around some of our more difficult challenges that we have. And a lot of that was based around some of our applications which are Windows 2003 based. They're on out of support operating systems. They're still in production, very little maintenance, so we don't want to spend too much effort on modernizing those. So the approach we took for that was, let's try it, let's see if this works. We took one of those applications, the largest and the most complicated application, and we, not nicely, but shoehorned it into a container. So at that stage, we didn't follow best practices, we just wanted to see if it would work. So there's lots of manual execution, lots of jumping in, doing some PowerShells, but we've got it in and we've got it working. We were able to then present that to our clients. We showed them that it is possible. And on the back of that, we got commissioned to do a piece of work, which is to do this properly using best practices and create a pipeline for migrating a few 50-odd services into containers. And that's what we're going to talk about. So large Windows 2003 estate. So the platform we've designed, we have a number of principles. It has to be highly available. Everything is infrastructure as code and fully immutable. Working in our clients' environments, AWS accounts, we had some constraints around how that was designed, so we've had to align our platform into that space. And that started up with one ALM, so an application lifecycle management account, which is shared. We have a separate dev account, AWS account, with two VPCs, an internet-facing DMZ and a private internal-facing VPC. And then we have a production account as well. We're again with the same, a public-facing DMZ and a private-facing VPC. The first step we build is a 3-node Docker master cluster. Also on those we install UCP, so that's part of Docker Universal Control Plane. We've then got a 3-node DTR, Docker Trusted Registry. And we start to build around some of our more shared components. So we have a 3-node Elastic cluster, ALM tooling. So this is where we store our Git repositories, any supporting infrastructure, Prometheus, Jenkins workers, and all the rest of the peripheral services we need on our platform. And we also have some persistence. So we use Gluster file system to have some persistence, not for things that are high IOPS in terms of write, but stuff that's low latency, low IOPS. But we can store some persistence for our applications. We back DTR off to S3, so all the data is stored in there. And then in the application environments, we have a pair of ingress controllers, and then we have our workers. So in this case here, those are Windows machines, and there are Windows workers that we deploy the applications on. All of these are inside of auto-scaling groups, so they're highly available. And as part of that, we have had to make these pre-baked AMIs, so nothing gets configured on startup, it's all pre-built. And this is a mixture now of Windows and Linux machines. So for the Linux side, we build these AMIs. They are sys level 1 hardened, and then AMI snapshotted, so we use those. For the Windows workers, we take a AMI from the marketplace, which is sys level hardened, and we use that, and then on top of that, we put some agents on. Those become our baseline images that we build the rest of our environment upon. As this starts, running these in auto-scaling groups had their own challenges. So when these machines first start up, as part of the bootstrap that gets kicked off, they have to work out what they're going to do. So am I joining an existing cluster? Am I initiating a new one? What role am I going to perform? Where do I sit? So what tags do I use? We use a lot of introspection as part of the boot up process that queries AWS, queries the CLIs, and starts to figure out what it needs to do. So that makes it very highly available and easily scalable. So if any particular node fails for whatever reason, it joins back up again. It knows what it has to do, join an existing cluster, and get back up healthy very, very quickly.
Yeah, I guess the key to that, it's important so in AWS, you've got the 3 availability zones. With the managers in DTR, you've got that 3-node quorum that must be maintained. So we have the ability to lose an availability zone. They will automatically self-heal in an existing one, and your quorum will be maintained, and therefore your cluster remains stable.
Yeah. As part of that, so some of the things we have to do is if a DTR node fails and comes back up again, it needs to get rid of the previous failed node before it can join the cluster again. All of that logic is baked into the bootstrap process. And then we mirror the same setup in our production environments. The only thing that we don't use in there is the DTR, so we keep a single DTR shared across both a non-prod and our prod environments. And the reason for that was that we have a single point of truth, so the images are in one location, and we don't have to repeat and push them across them. That's the approach that we've gone for. So what we're going to do now next is show you a demo of this environment. Not this full environment, we have a cut down version of it, but we'll be able to show you a lot of the way that we build and deploy into this environment. So I feel a little vulnerable. I've had no grapes today, but let's pray to the demo gods and hopefully this all works.
Yeah. There we go.
There you go.
So what we have here is a Windows .NET application running in a Windows Server 2016 VM in Azure. So what I'll briefly do is pop into Git and just make a code change. So what we've done essentially here is taken all of the Windows 2003 source code that existed in Team Foundation Store, and then moved that into Git. It was exactly the same source code that we're using in order to build our Docker image.
So whilst this process is now a lot quicker than it is doing it manually, Windows containers are still slower than working with Linux. So what Arthur's doing is making a few changes, and then once he's made those changes, we can go through and we'll talk about what the changes are, what we've done. As part of the principles of our platform, we wanted this to be very much a GitOps focused application, a platform. So any changes that you make are driven through source code. So you update your configuration, your source code, and that triggers the behavior. We've prevented users from any users to be able to push directly into DTR. All of our images that are used in the platform are built within the platform. We have full end-to-end auditability of who's done what and what's triggered what behavior. We've also kept this very much self-sufficient as well. So it allows our development teams to go in, make the changes they need, and we'll talk about this in a second, but we also use a smart ingress controller, so our load balancers, which is traffic, which allows the application teams to assign tags as part of their deployments, which will configure the load balancers, and they can do other things like use context-based routing, do blue-green deployment, and all of that is controlled by the dev teams without having to have the platforms team or any other ops team get involved.
There we go. So you can see in the background there, while Indy was chatting through that, I made all the code changes in Git, and it's initially kicked off our pipeline, which is going through, pulling down the code, and it's starting to build our image. So while that's building, I'll have a quick talk through what I changed there. So as I mentioned before, this was all our source code we have for Windows 2003 .NET application. In case you missed it, I changed the tag from magenta to blue here.
So we're not the dev guys, this is the quickest change that we can make.
Yeah, it's nice and visual as well. So after that change, even though I committed that change through, our pipeline won't build. To maintain the control with the developers, our pipeline doesn't build until the Docker file has been modified. So these labels here are maintained by the development team. And until this tag is updated with a new commit point reference or a new version, I up the version to 6 in this example, our pipeline won't start initializing the Docker file build. Because as you imagine, multiple code changes are going into your repository. You don't want to be building the image constantly all the time. And then if I pop back a step, going to deploy, I modified the Docker Compose YAML file to reference the newest version that I am building. Alongside that, I created a new Git tag, 20blue. You see magenta is running there at the moment. And what that I will show you later on in the demo, but what it gives us is the ability to deploy that tagged version into our swarm.
So at the moment, Arthur's making the changes directly in the Git on the master branch. That's again just for demonstration. It's not what we would do. We can enforce policies within the Git repositories to ensure that you don't merge your own code, all that good stuff, following the dev practice. But for a demo, we're just doing that. So that's building. So
it's just started its image scan in DTR now. So if I do hop into DTR, that's UCP, don't want that.
Yeah, this is the
internet let me down.
Yeah, try again.
There we go. You just see image 6 is there, pushed up now, and you can see it is scanning. There we go.
So if we look at the logs on there, we can also see that it's
yeah.
scanning in there as well.
Yeah, so it's constantly looping around, making sure that the job for scanning is complete.
That's done. Okay.
Still waiting.
Yep.
But if you pop further up, you can see that it's taken, oh, not quite.
So it uses those tags the tags that the development team are put into their Docker files. We extract those tags out of the container and we use those to label the push. So we extract those variables out, and that's the label that gets pushed up into DTR. So again, all of that gets configured by a couple of files, and it's all in the control of the development teams themselves. So we're still waiting. Okay, so while we're still waiting for that, so that's the first part we're showing you. So this is how we're building our images and containers. The part that's really cool is now, if you just lift and shift this into a new environment, you still got to work out how you do the rest of your application monitoring, how you do the support, how do you know what's going on. And these are old applications. These are Windows 2003, so they use things like BMC and the whole raft of other older stuff. But working in this newer platform, we can start to get modern tooling deployed into this environment. So if we go across, so we're now logging all the Windows logs directly into Elastic. So we use FluentD to extract the logs, send them to Logstash, send them to Elasticsearch. We use Prometheus to start getting metrics across all our Windows machines and our Linux machines. It's in a single pane of glass view, so we know what's going on everywhere. So that in itself totally modernizes the way we work in. So yep, it's still an old application, but you start to grow and you can normalize all the rest of your tooling stack as well. And we've been able to do this. We've done this with a number of services now, and we've made 0 application changes. There are slight config changes, but config changes are always there to be changed between the environments anyway. So there's nothing there. But we have done this without any application code changes as well.
Yep. So that's fully finished now. If I just hop into the log, this one here. I guess not only would you see any vulnerabilities there in DTR, but we also report that out as part of our pipeline job. So that will go off to the development lead, a change manager, whoever then decides that image is fit for its next stage in the pipeline, next environment, or whether it does go to prod. We left that up to the customer or to the developers to decide whether those vulnerabilities are acceptable in the production environment. So now it's built, I can deploy that into our environment.
So at this stage, we had an option which we had to consider, whether we do fully automated deployment straight into your environments, or do we have a pause? We went for we'll have a stop, it becomes a manual intervention for someone else to push this through. A lot of that is more to do with the cultural change and our clients getting used to this whole process. But we've made this painless as we possibly can. So what we're doing here, what Arthur's going to show you now, is the deploy part.
Yep. So you saw me do a tag earlier in the GitHub repo, GitLab repo, sorry. But essentially what it's doing is it's going off and querying Git's APIs to populate the app name and the tag versions that you're going to deploy. We've only got one environment, no, we've got 2 environments in here, but we've only got ST, is the only one that works, so we'll be deploying to that one.
Yeah, so the reason for using the tags was it forces it, so you can't just take the latest commit point, it's not a typo, or you picked the wrong commit point. It has to be, you have to have made a conscious decision that you're going to tag this. And that can be, it doesn't matter what format you call it, you can call it wherever you want, call it Mickey Mouse, but it has to be tagged. And the tags are immutable, so that means you can roll back, you can roll forward, you know what was done and who's done it all the way through the life cycle. Okay.
Right, so that says that's deployed, so it should be bouncing in the background now. There we are, that's it gone down.
So yeah, so Windows containers do take a couple of minutes to start. But if you imagine this, what the process used to be to deploy these applications, it was a long, complicated process. So it used to be, the code used to be compiled, built, handed over to a team. They would move them onto the application servers for you. Then another engineer would log onto those servers, open up the MSI, do a GUI-based installation, install it into the environment, and then you get it. What we've just done in the last 8-10 minutes is done the whole process of building the application, pushing it up to the registry, and deploying it. And you can see it's up and there running, and that's taken, 8 minutes? Yeah, anything else to add on that one?
No, I think that's that demo done.
Yeah. So this is your legacy application. This is the way we work. So actually, no, we need to talk about the multi-stage builds.
Oh, yes.
So as part of, when we said the first iteration of the build was done in a very manual, dirty way, we wanted to make that process a lot more robust and follow Docker's best practices. And this is what the multi-stage build part is.
Yep, so we have a custom base image that we've done with all our build tooling into it. So we start with that, pull our source code in. You can see the commands here, copy in configuration files in, and do some NuGet packages. And then from that, we have another custom image that we use to run our containers in. And from the back of that, it is taking the configuration that was built in the previous image and then importing into that image, making sure that our production build image doesn't have any of the build tooling inside of it at all. All it has is what's necessary to run the app.
Yeah, so that makes it a very lightweight, or the lightest weight possible that we can have for our run container, but we still build everything from source code within the environment. And the custom build tools base image gives us that capability, so we can build that. The application developers can use the same image when they're doing the local builds on their workstation. We can use the same image here, but we don't want build tools running in your environment, in your container that your application's in production. So we can take that out, we can separate that out, and we have a very lightweight run container.
Yeah.
Okay, so this platform, so whilst we've shown you what we've done with Windows, it doesn't have to stop with just Windows and legacy applications. We've taken this to the next level there. So what you're seeing now is this is the platform that it's running on, and we've stretched it. So we've stretched this platform globally across the world, across 4 cloud providers and multiple regions. So we're running a Docker cluster, Swarm and Kube across AWS, DigitalOcean, Azure, Google. And it's as far west as San Francisco and as far east as Singapore. So it's totally stretched across, all talking to each other. And we've got a couple of services deployed on there. So one of these is this one here. So it's a very, very lightweight dummy app again. Based on our points, it's very small, 4 meg or something like that. So this is what we would say is really like our current application development. So any apps that we're working on at the moment are microservices based. So this is our dummy microservice. And we can do some pretty cool stuff with this. So at the moment, there's only one instance of that container running, and that's what we're seeing here. I can scale this up. I'll scale up. So what I've just done is kicked off a script. That's going to scale this to 200. And as you'll see, because it's a very light image, it's microservice, you can start to see it's starting to scale up. The page itself only refreshes every minute, so it's slower in the count. But in reality, if you look at the top right-hand corner there, it's rapidly going through that scale up. So if you give it a few seconds, we can go into details and we can show that we deployed this application across multiple cloud providers, different operating systems, and we don't have to actually do anything to tailor it or specify how you work on the different providers. So it gives us that ability to rapidly deploy cross cloud providers but in the same way that we would do the single application. So that's just waiting to verify. Give me a couple of seconds. Okay, so if I do Docker stack ps cb, so it's a bit hard to see, but you can see that we are running the application in Toronto, in Bangalore, on AWS, in Google, and there's 200 instances. That's allowed us to scale up rapidly. I mean, okay, this is, like I said, still a demo, it's a demo app, but you get the idea. And just going back to this, so that's the rapidly scale. So we're just showing you how easy it is to use this platform to rapidly scale up. But that's where we currently are. We also wanted this to be a bit more future-proofed as well, so try and intercept what's coming next. And for us, it's functions as a service is where we're seeing a lot of involvement, lots of people interested, lots of people talking about how we do this. So up on the screen is a industry-defined definition of what functions as services are. Not going to read it, but you can have a quick scan through. But basically the way we saw that was, currently we're having to manage servers. And this is a picture from Back to the Future 2, which is the 1985 version of what 2015 was. That was a few years back, so we actually, we grew up watching this film. We're actually in the future, so it's about time we started working in a slightly different way. So what does that mean? So we are all still remember when we used to look after our servers, they were pets. We knew them, we labeled them, we knew what they were, we had little custom scripts and little favorite boxes. We want to move away from that. And then we've got to where we are currently, and this is a bit more like cattle. So we're starting to treat that. So we have X amount of workers, we've got cluster over here, cluster over there. We've sort of moved away from actually having, naming the boxes, getting onto them, SSHing on. But we want to get totally away from that. And it's just, all I want is my product. I want to go to a supermarket, pick up my consumable. I don't care how it's got there. I don't care where it was built, how it got delivered. I just want the end result. And that's where we see functions playing a part. So all the big three providers have functions available. But if you look from the table there, that's not a lot. AWS has got the most, but it's hard to get each one of these to be able to go cross-platform and have the same availability of all your languages. We've used OpenFaaS as our functions platform, and that's allowed us to do the more popular languages, your Javas, your R, your Scala, but we've also done some quite interesting ones as well. So COBOL and Whitespace, which we'll show in a second as well. So as part of the demo, what we're going to do now is on that platform that we just showed you earlier, which is running across the world, we're going to deploy OpenFaaS on top of that and then deploy some functions. So let's go back. So if you're not aware of this is the OpenFaaS UI. So if we go into this, you can see we've got 5 instances of that function running. I can invoke it, and we get some response back. Again, this is a very lightweight function. All it's really showing you is where that function was executed. And this is information we get back from that. So this is the IP, or where it was, what city, etc. is run on, and that's what we get. And we have, again, we use the same tooling, so it's Prometheus backed Grafana, Grafana dashboard. And that starts to show us the functions that are there, what's currently running, how many replicas we've got of that type of function, and how many requests. So at the moment, there's only been 2 requests. Now, if I put some load on, what we should start to see is that count increasing, and the number of functions and the number of responses growing up. We also use this tool here to start to visualize what's actually happening in the environment. So as you can see, it's coming across 4 different regions at the moment. As the load persists, it starts to auto-scale. So what we should see right here, in a second or two, that this count, which is currently on 5, increases to, I think it's 15 it goes up to. And that's part of the platform. It does auto-scaling within the platform. So there we go. That's increased now to 15 instances of that function that's running. Going back to this view here, we can see there's more boxes available, more circles appearing. And again, some more. So what that there has triggered yet another increase. So that's going to refresh in a second. So that gives us the ability to, on the same platform that we're running legacy applications, same platform we're running microservices on, current gen, and also where we're seeing the future coming through in functions, it's all running on the same platform, all being monitored using the same tooling, all built the same way. There we go. You can see the traffic's flowing all the way through. And like I said, we've got some pretty interesting languages. So this here, if those of you who can't read the text and make it out, this is a language called Whitespace. And it's all written in tabs, spaces, new lines, characters. And if I execute that, we didn't code this one. This again is just to show what's possible. If we execute this, we get a response back. So this is a function written in Whitespace as a language, and it's working. I don't even know where it's running, it's somewhere in the world. But it's running, and we managed all that. We deployed all of it using the same tool set that we're using to deploy our legacy applications. Okay. And obviously, that's a platform you can see now. It's currently running up to 25 instances, 35 instances of that. As soon as the load drops, it scales back down again. And all of this is baked into the tooling itself. So again, it's a great way, and this is one of the reasons why we think functions is going to be what's coming up next, because it allows you to get that granular control over what your applications are, run them across, and you can API enable some it's very easy to do. You write your code, development teams just focus on the code. They don't really care about how it's packaged, where it's run. but you can build it and deploy it very, very easily. Okay, anything else?
I know, I think you covered everything there.
All right, I think that's all we've got to show. So, any questions?
Anybody have any questions they want to ask? I've got the microphone.
So,
There's
guess
one at the back there.
Oh, yeah.
Yeah, I just want to know about you showed about the your entire environment spans across multiple region and different public cloud, right?
Yeah.
So how you span your UCP masters and worker node across multiple? Is it UCP master is only in one public cloud and the worker nodes are spanned across different public cloud, or is
yeah. So in this environment, 'cause it's demo, we've only got the single master. But where we have done this, where we're going to be doing this going across multiple clouds for real, we will keep the masters in one cloud so that you get the high availability, low latency, and we can distribute the workers out. That does mean if we have an outage, you can't change the state of your environment. So if a whole region went out, you can't change the state of your environment. But as the workers could still run, you won't have a loss of service. So the impact, whilst it's not ideal, it's not a showstopper.
I think to add to that is Docker's recommendation for the managers is to keep them as close together as each other because the algorithm they use to communicate with each other needs to have low latency anyway.
yeah, because they have a latency requirement, a certain latency requirement across UCP manager. And what is your recommendation in terms of if I want to split UCP masters across multiple availability zone? Since we always need to keep odd numbers, right? So if I keep 2 in one availability zone, 1 in other, if that bit goes down again, we lose the quorum, right?
That's right, yeah. So in the scenario where you've only got 2 availability zones in AWS, if you do lose that one with 2 in it, you've lost your quorum. We're lucky in the environment that we're built in that we've got 3 availability zones, so we managed to spread our managers across all 3. So if we did lose one, then it'll recover itself and give you quorum again. In the unlikely event that you lose both, you lose 2 regions, then you would lose quorum. Yeah.
Okay.
But again, that's a double failure. So there's going to be lots of things that are affected by that, but you can still have a service that will be running.
And last question with respect to the auto scaling, what you have shown with serverless. So is it that tooling is part of the open fast platform, or we need to do some other tooling to achieve that?
So as part of the open fast platform, there is a number of different services running in there. So Prometheus is deployed. Prometheus is capturing how much traffic is flowing through and is doing a count of how many requests are done per second. If a sustained load is there over a certain amount of time, it then triggers an event which does the scaling.
But if you talk about Swarm doesn't have any auto scaling feature, right?
No.
Then how that function?
Well, on that argument, neither does Cube. Cube uses plugins and other containers to do the work for you, and we're doing the same thing in Swarm now. So Prometheus is reading the metrics and then alerting on those metrics and then invoking an auto scaling function.
So it's only scaling at the container level, so it's increasing the number of containers.
Yeah.
One of the advantages we've got with what we've done here, because all of our workers are running in ASGs, we could put some metrics around how busy each node is, and then if they hit a certain threshold, we can scale up and scale down. So we've done that with another platform, what we've built, which is again serving some critical national infrastructure, and that uses that concept. So we monitor the metrics of each of the workers, and then we scale horizontally where we need to.
Okay. And is the source code is available in GitLab, which we can use, or no?
So this isn't open source yet, no.
Okay, thank you.
I forgot to mention this. We've got some slides on the back there, which just shows the current capability that we've deployed across this platform. We've not been able to cover all of it because of the time, but if you've got any questions around that, we're more than happy to take them.
Any other questions? I think we're good.
We'll be around for a bit if anybody does want to come and speak to us.
Thank you. Thanks, guys.
Thank you.